Course 3, Lesson 21, we are looking at the distributive property, being able to factor things, and using the order of operations. So the distributive property says we have a single term outside of parentheses, and it's going to be multiplied by 2 or more terms inside of a set of parentheses. So when we look at our first example here, A times the quantity B plus C, the distributive property tells us that I need to take this A and multiply it by the B, and I need to take the A and multiply by the C. Now I know that there are 2 terms in here because this addition sign separates them. Terms are separated by addition or subtraction signs, so I have B and I have C. So that I get A times B, A times C, and that addition sign stays between the 2 terms. So when we look at our next one, we do 6 times 2 and 6 times 4x, so that we get 6 times 2 is 12. Here we go. Almost. There we go, 12. And then 6 times 4x is plus a 24x. And the question is, can we combine them? The answer is no, because 12 and 24x are not like terms. So it actually stays as 12 plus 24x. The next one, we can still use the distributive property, and we can do 2 times 12 is 24. 2 times 8 is 16, and since there's an addition sign right here, we are going to add these together and get 40. Now I know that there are other ways to do that one. We can simplify within the parentheses first to get 12 plus 8, which is 20, and we multiply by 2, which gives us 40. So either way ends up working. For this example, we say, all right, yesterday Miss Hornblower bought all 8 Harry Potter DVDs at the store. DVDs cost $9 each, and today she bought 6 Hobbit Lord of the Rings movies. How much money did she spend on DVDs? Now, we can show this in a couple different ways. One that will require using the distributive property, and one that you've probably seen before. Okay, something like this. We do 8 times the $9 and 6 times the $9. Or we can use the distributive property with this one to say 9 times 8 and 9 times 6, which will give us 72 plus 54. So she spent $126 on those movies. So we can use the distributive property in word problems too. Just like with this one. The school cafeteria sells an average of 30 apples and 20 bananas every day. How many total pieces of fruit do they sell in 1 week? 5 days. So we can show it as 5 times 30 and 5 times 20, or set it up so that we can use the distributive property to get 150 plus 100, so we get 250. Okay? Either way, we will get the same answer. Okay? Either way. So using the distributive property, we can continue on, always looking to simplify at the end if we have like terms. So with this first one, we need to do 2 times x and 2 times 3x, so we get 2x plus 6x. Since these are like terms, we say we get 8x. We can do the same with number 2. We get negative 5 times n, negative 5n, and then we get plus a negative 5 times negative 7, well, that's a positive 35. Since 35 doesn't have an n, these are not like terms, so we can't combine them. Next one, we do negative 8 times negative 2, which is a positive 16. And we can think of this in a couple ways. We can subtract what we have here, negative 8 times 3w, which is negative 24w. And minusing a negative is the same as 16 plus 24w. Or we can think of it as doing this negative 8 times a negative 3w will give you a positive 24w. Either way. We can't combine them because they're not like terms, so we leave it as is. And lastly, we get negative 6a plus a negative 24b. And we can say this like it is right there, or we can say negative 6a minus 24b. The second one there is a little bit more simplified. All right. So, practicing a couple more. 7 times y plus 3, we get 7y plus 21. 8 times m minus 1, we get 8m minus 8. 5 times the quantity 4x minus 5, we get 20x minus 25. Negative 9 times the quantity 4 plus 2n, we get negative 36 minus 18n. We have to distribute that entire negative 9. Now, distributive property and factoring are opposites of each other, so we can go back and forth from them. Factoring is writing the expression as a product of two or more numbers and expressions. Basically, what we have here, that is the factored form. We have two or more expressions being multiplied together. And here is our expanded form, what we get when we do distribute. So we basically want to say, what did we come from? What was the factored form? And the first thing we have to ask ourselves is, what do they have in common? And we can see they have an a as a factor in common. So our first method is to divide it away. Don't worry, we'll multiply it back in a second. But we find what the greatest common factor is, and we divide it away so that we have an x plus y left over. Now, since our original expression and our new expression are not the same, we need to fix what we did. We divided by a, so I want to multiply all of this by an a. We basically say our first step is, what do they have in common? Find that GCF. Second, we divide it away, divide that GCF from both terms. And then the third part, we multiply it back outside of parentheses. We multiply that greatest common factor. So let's practice that on a couple of these. Okay, we'll try these later ones in a second. AB plus AC, they have an A in common, so we divide by A, and we have a B plus C left. But remember, we need to multiply our greatest common factor outside of the parentheses. Because guess what? If we were to check our answer, which we always should, we would distribute out and get an AB plus AC, which is exactly our original expression. But now we have it in factored form. MP plus PW, we have that P in common, so we divide by it and get M plus W left over, but since we divided by the P, we have to multiply by it on the outside. We divide by H in the next one, and so we get G plus N and an H on the outside. And lastly, we divide by R and get B plus Q with an R on the outside. Now, the next way that we could do these factoring problems is figuring out, okay, I have these numbers. It especially is helpful with numbers and exponential expressions. But we have numbers that we want to put it in their prime factorization. So 9 would be 3 times 3, and 6a would be 3 times 2 times a. What this helps us do is realize, actually 9 and 6 do have something in common. We have a factor of 3 in common that we can pull out. We can say, all right, that 3 can be pulled out of each of those, and we have a 3 plus 2a left over. We pull it out to the outside and just have one of those on the outside. Similarly, with 13, we could do 13 times 1 minus 13 times 2 times b, which means we have a 13 in common with each of these. So we would say, all right, 13 goes on the outside. I'm pulling that out of each one, and we do 1 minus 2b. And that is our factored form. Okay? Now, we could get even more complicated. Let's say we do something like 12x squared plus 8x. And we put these in our prime factorization. So we would say, okay, this is 2 times 3 times x, and the 8x is 2 times 2 times 2 times x. Now we could say there's a lot in common. I actually have 2 2's in each of these, and I have an x in each of these. So I could pull out all of that and say I'm pulling out a 2 times x, and in the parentheses I have left a 3x plus 2. And we could simplify the outside to say we have a 4x times 3x plus 2. So use either of these methods, whether you're dividing out that greatest common factor or putting it in its prime factorization and seeing what we can pull out. Either way will help you factor. Now the last part of this lesson is about order of operations. We have to go in this order to make sure that our expressions come out the same every time. So we first need to simplify within parentheses, then simplify exponents, then on the same level we multiply and divide, and then on the same level we add and subtract. This is what I mean. Let's look at this example. First we have to simplify within the parentheses. That means that in the parentheses we get 6 plus 5 squared minus 10. Now we have to do the exponents. So we still have that 6 plus 25 now minus 10. Since we have addition and subtraction, we have to go left to right. So we do 6 plus 25, that's 31, minus 10 gives us 21. All right, so whenever you see addition, subtraction, we go left to right. Whenever you see just multiplication and division left, you go left to right. So in this case, we would need to multiply first and then add. Okay, so we multiply 10 and 5 to get 50. Add it to 50 and we get 100. All right, once again, we need to multiply first. Okay, and we get, I'm looking at this left side here, we get 30, add 5, and we get 35. On the right side, we don't have any parentheses, so we need to square things first. So we get 16. And then since division comes before subtraction, we divide and we get 8. So 20 minus 8 is 12. So here we get 35, and the other one we get 12, using those order of operations. Okay, so for this next one, we need to do our exponent first to get 16. Oh, this is actually the same as the last one. Sorry about that. Let's look at a new one. All right, parentheses come first, so I need to do 4 times 8 minus 5 is 3, and then I multiply to get 12. All right. Next one, I need to do parentheses first, so I get 5 squared times 3. I need to do those exponents, so I get 25 times 3. So my answer is 75. All right, just follow order of operations. Now what happens when you see something like this? 12 minus 7 plus 3 minus 6. Well, we actually have to go left to right. Since just subtraction and addition are left, we go left to right and actually start with 12 minus 7. So we do 12 minus 7, which gets us 5, plus 3 minus 6. We add 5 and 3 to get 8 minus 6, which gives us an answer of 2. All right. Let's see. All right, a little bit more complicated. Let's do this as our last one. Parentheses first. So we keep everything else the same. 20 minus 2 times 3 squared plus 15 divided by 5. All right, we do exponents, so we have 20 minus 2 times 9 plus 15 divided by 5. Now I need to do multiplication and division, so I go left to right. Whenever I see multiplication or division, I do it. So now I have 20 minus 18 plus 3. I continue and I say, all right, 20 minus 18, I go left to right. 20 minus 18 is 2 plus 3 equaling 5. So hopefully this helps you understand order of operations, distributive property, and factoring a little better. I hope this helps for your homework and for studying.